Okay, Chem, today we're going to talk about the trends on the periodic table of the elements and what causes them. So the things that cause the trends are two different things that we're going to treat separately. And the first one is going to be Coulombic attraction. A coulomb is a unit of charge, and in this case, the charge that we're talking about is the positive protons in the nucleus. So Coulombic attraction. And Coulombic attraction is responsible for all of the trends across a row or period. So we're going to deal with the second principal energy level for our session today. Our abbreviation for principal energy levels is our N number. And our second principal energy level is lithium through neon. So that's atomic number 3 through 10. Remember, those atomic numbers refer to how many protons are in the nucleus. So I'm going to make my nucleus super big compared to what it would be. Let's draw a line around what I'm going to consider my nucleus here. Just for this lesson. That's going to be my nucleus. That's an exaggerated nucleus because nucleus is actually super, super, super tiny. So the analogy is if the atom was the size of the football field, then the nucleus would be like a fly on the 50-yard line. That's how tiny it is. So let's not get confused and think that a nucleus is big because we call it massive. We call it massive because in that tiny little area, it has all the mass of an atom. So let's deal with lithium first. Lithium has an atomic number 3, and if you remember from previous lessons, that means that lithium has 3 protons in the nucleus. If we have an atom of lithium, it also has 3 electrons. 2 in the first principal energy level. That's the electron for hydrogen and helium. And then it has 1 in the second principal energy level, like such. So lithium has 3 protons in the nucleus pulling on these 3 electrons. So how much force it can pull on this electron has to do with the quantity of charge. So these charges are pulling on the valence electron. Now let's go to beryllium. Beryllium has 4 protons in the nucleus. So more protons in the nucleus, but same principal energy level, same electron shell. So he's got 2 in the first and 2 in the second. So what pulls on these is the protons in the nucleus. I have more protons to pull on them, so he can pull with more force. And we're going to keep going on, and we're going to do, next would be boron. He's got 5 and 5 electrons, like such. Carbon has 6 protons and 6 electrons, so we're getting better and better at pulling on our outside electrons. So the electrons are pulled with more force, held more tightly, and held more closely, all the way across. This is nitrogen with 7 protons in the nucleus and 7 electrons, 2 in the first principal energy level and 1, 2, 3, 4, 5 in the outer levels. Then let's do oxygen. He's got 8 protons, 8 electrons. He's better at pulling on his electrons, so he's pulling them with more force and pulling them closer to him. So he holds onto his electrons more tightly, and he pulls them closer. This also makes him very small and better at pulling on other people's electrons also. And then we've got fluorine with 9 protons in the nucleus, 9 electrons total, and 7 valence electrons. he's really good at pulling on his electrons. So let's put a little star there. He is the most electronegative. So fluorine is the most electronegative, meaning that he is the best at pulling on other people's electrons. He has the highest ionization energy, and I should have mentioned this before. When we talk about trends in the periodic table of the elements, we're usually excluding the noble gases because they don't pull on other people's electrons because they have a full shell. So ignoring the noble gases, he has the highest ionization energy, meaning that it takes the most energy to pull an electron away from him, meaning that he does not want to give up his valence electrons at all. It takes a lot of energy to get him to give up his electrons. He is also the smallest radius in his row or period. So when you talk about a period on the principal energy level, and remember we're only talking about the second one, lithium is the opposite. He is the least electronegative, meaning that he is the worst at pulling on other people's electrons. He has the smallest ionization energy, meaning it takes the least amount of energy to get him to give up his one valence electron. And we're going to start to abbreviate these guys. Electronegativity is going to be En, and ionization energy is going to be IE. He also has the largest radius in the second principal energy level. So that's Coulombic attraction, and all of the trends as we go across a period or principal energy level or row, all of those trends are caused by Coulombic attraction. If you don't remember Coulombic attraction, you can simplify it for yourself, is the pull of the protons on the oppositely charged electrons.